Hi everyone, my name is Pankaj Verma. Here we are going to test the VRF concept on the NSX 3.1. We'll be testing two use cases. One use case will be for just one VRF within a data center and between data center. And the other use case is that we will be having two VRF, blue and red, and we'll make sure that we are completely isolated in a same data center between two tenants, blue and red. This is my topology for the use case one. We have this is physical and underlay environment. I have a laptop connected on a VRF red. We have a red VRF. I have a laptop connected on this VRF, and we have a tier 0 a local router. That is the global one. It is not it is non VRF router. And simulate that data center 2. We have another global tier 0. Then we have a tier 0 red VRF logical router here on a data center 1 and similarly on data center 2. And then we have a respective tier 1 for the red VRF, and we have a segment here. These are the two test VM connected on a same segment, red VRF segment. So we have from my red VRF tier 0, we will have a direct BGP session with the underlay. And this has a VLAN 210. This VLAN 210 are a VLAN backed. So from underlay, we have a VLAN 210 extended all the way to this tier 0, so that we can set up a BGP session from underlay, that is my Cisco switch, up to the tier 0. So Cisco switch is also configured for the VRF. I'll just go with the physical switch configuration first, and then we'll come back to the NSX configuration. This is my physical router. I'll talk about show IP VRF red. So we can see that I have some test interfaces configured here: loopback 60, 100, 160. This VLAN 20 is my VRF on which my laptop is connected. We can see that show run interface VLAN 80. That is 192.168.1.1. I have my laptop connected on the same VRF. We can say IP config 1.40 is my IP address. So now going back to the VLAN 210. So if I go to the topology here, this is the VLAN by using which we will be creating a BGP session from underlay to the to my VRF red here, tier 0 VRF red. Okay, so going back here, we can see show run interface VLAN 210. So we have a segment of 210. 1 second, it is 150 also. I think 150 also. We are using 150 VLAN. So I'll just little correction here. Or we can use any of them. So let's go with the 200. We'll use the IP from this range. Okay, so going back to my NSX configuration. Okay, this is my NSX for this data center 1, NSX managed data center 1. Here we have a network topology. Here we have tier 0. So first I'll talk about the global tier 0. This tier 0 is required to have a transit connection from VRF tier 0s up to the underlay. So this is pre-configured. I'll just show you the configuration here. What we need to configure. This is my CDC tier 0. This is the edge cluster, and then the interface. This is the global interface we have created here. Just a connectivity between global tier 0 to the underlay. So this is the IP address. So this is just in configuration for the global tier 0. We need to focus upon the VRF tier 0 router. So to configure VRF tier 0, first of all, we have to have a red VRF segment extended from underlay up to the VRF. So for that, the first step would be create a segment for that VRF. So here we have a segment. This red VRF segment or red segment is already created here. That's a VLAN backed. So if we go here, just see that what is that the configuration of that. Sorry, this is blue one. Yeah, this is red one. You need to just give the name here. We have a name here, CDC red VRF, and Here we have a VLAN 150. So like we are showing that 200 there. So it is 150 here. Okay, so, or we can create one more. Let me create one more just to create another segment. So we'll say CDC red VRF seg02, and this is my VLAN backed because that is how we need to connect to the underlay, and here we need to give VLAN 210. That's it, and say save. Okay, no. So now we have created an red one segment 2. Okay, so this is created. So what we have done, we have created a VLAN 210 here, and this is an IP address. I'll just correct an IP address for 210. It is 200, so let's correct it to 200 and 2. Now next step is that, okay, so now we have a new VRF red segment. I'll simply correct the name here. It is VRF red. Okay, save and close. Now go to the tier 0 and create a tier 0 VRF to connect to the BGP session with the underlay. So we'll say tier 0, it's a VRF. So VRF, here we can name it as CDC and red VRF BGP. You can say connected to. So this is the tier 0. That's my global tier 0. This is this tier 0. So that we need to have that the VRF tier 0 must have a non-VRF tier 0 to connect to the underlay. So that is what we need to choose in. We say save and now configure. So now we created this red VRF tier 0 and connected that to this tier 0 for now. Now we are going to configure the interface connected to the underlay and then connect the BGP session. So now next step is that go to the interface, set the interface, add the interface, put a name. We can say CDC red VRF uplink. So this is the uplink interface which is connecting to the underlay physical interface. Okay, and here we need to give an IP address. So we had an IP address for VLAN 200 is 201. So we can give an IP here as 2 because 1 was the given at the underlay. Then 29 is the subnet mask. Connected to segment. So this is the segment which we recently created, that was CDC red VRF segment 2. Here we can select on which node we want to create. You can say 2, and yeah, that's it. Sorry, let's take a VRF1. Yep. Close. It didn't work upon the edge node 2 because there was already one configured with this with that for that VRF. So that is the reason it gave an error. One edge node cannot have 2 tier 0 from same VRF actually. That was the error. So close here, and we can see that it should be success. Yes. So now we should be able to ping this interface from my router. This is my physical router. I should be able to ping it. Ping VRF red, and let's see. Ping VRF red. Yep, it's pinging. Now next step is to configure the BGP. So here we go to the BGP session and simply say enable. This BGP local AS number, it inherits from its parent tier 0, this one. We cannot configure it or change it for the tier 0 VRF routers. We simply need to say enable, and we can change if we need to make some parameter changes. By default it is there only, and simply go here and say set. Now my neighbor is 1 and my remote AS is 100. This is my remote AS for my router. show IP BGP, say BGP VPN v4 all summary. So this is my local AS 100. Okay, so I gave 100 and it says that select an IP address source. So this is the IP which we just gave to the interface source and say save. Before that, let's see the BGP neighborship here. Show IP BGP VPN v4 VRF red summary. Okay, we do not have, we didn't configure anything 192.168 with this IP 200.1. Okay, so we'll say simply close it and save it. Okay, so now we need to configure on the my physical switch. You can go here, so router BGP 100 address only IPv4 VRF red neighbor, we can say what's the neighbor here, 200.2 remote AS 65001, and we need to generate a default route. Okay, now we can see that BGP neighbor should be up. So IP BGP VPN v4 VRF red. Okay, summary. Yeah, so my BGP neighborship is up. As of now, I'm not announcing any route, so let's see that how to configure that. But my BGP neighborship is up. Now we need. Right. Hmm. Now the नया segment been configured. So now next task is to connect this tier one tenant or the router with my tier 0 red VRF. So let's create a new tier 1 here. I'll go here and say tier 1. Okay, at tier 1 gateway we can say name it same as CDC T1 red. Select the gateway. So my gateway must be my new uh, tier 0 VRF CDC, this one. Cluster we can choose, otherwise it take default. That's it, save. So my tier 1 is connected. Now we need to configure interface on that. So sorry, it takes the interface and all the routing by default. The only thing we need to make sure that we announce the route, we announce the connected route. So here we need to go and say route advertisement and say connected. Okay, and say save. So this way what we have done now, we connected the tier 1s with the tier 0, and whatever interface or routes will be connected here, by default it will be shared with the tier 0 red VRF. Before that, we also have to make sure that tier 0 is announcing the routes to the underlay. So if we go back to this tier 0 VRF, here we need to make sure that this router distribution is on, which is not set here. So let's set it here. Set add router distribution second any set. So this will be for tier 1. Tier 1 is sending the routes, but that we have to enable on the tier 0 VRF router as well, so that it can populate that to the underlay. So here we can say all connected, and if we have some static route, we can check it. On the tier 0 also, let's make the connected router distributed. So we can say yes, apply, add, apply, save. Now let's see if we are receiving any routes here. We should be getting some connected routes here now. Yep, we are getting one connected route because that's what we advertise from the tier 0. As of now, nothing is connected on the tier 1. Now next is that we will create a segment or use existing segment and connect to the tier 1. So we have a red segment here. We can say this is the red segment we created. Just check the configuration here. This is my red segment that we need to connect to the newly created tier 1. So we'll select it here and go here and say CDC tier 1. Okay, this is my segment which we can, this is the gateway. This is my tier 1 will be the gateway for any segment we define. So this is my segment connected to the tier 1. So if I go back to my just hold on. Yep. If I go my figure here, so this is my segment. So I've created this segment. This segment must be connected to my tier 1. So this is what we have done that, and this is my tier 1 connected to segment connected to tier 1, and this is then the default gateway. So save. Okay, now we will see that this segment must be announced. We should be getting this route into the underlay. So if I go here, we can see that now we are getting one more prefix here. So if I say show IP route VRF, or say simply say that, so we can see that from 65001 is my AS number. We start getting this route that we just recently defined. Okay, going back now we need to make sure that we have test VMs connected on a same segment. So if I go to my vCenter, this is my vCenter, this is my compute. I have two test VM. Both test VM are on the same segment, VRF segment. If I simply right click, and we can see that edit setting, red segment. And if I go here, it is also red segment. Red segment. Okay, now we can get an console of these test VM and see that where we are. Let me go and open this one as well. So we'll say root, and let's see what is the IP address we have. If config, it is 10, and the other one, sorry, this one, that application, sorry, system tools, configure networking. This is IP, we can change it here. I'll say 12 and start. Okay, and close all windows. Okay, we say if config, we have 12. Let's ping the gateway 10.10.113.1. We are able to ping the gateway. Let's go take the other VM and change that IP to the what's the IP here? Okay, if config. Okay, we can change 11 and 12 IP we need to make. So I'm just going to change that. System tools. Yeah, correct. Okay, that's fine. Okay, रुको मैं एक बार देख लेता हूँ. If config, ठीक है, to test VM, and this test VM 0 test 0 is on 10.10.113.11, and this is 12 as per the figure. If I go to the topology here, so this is 113.11, 113.12. So let's go back to the test VM. This is my test VM 01. So if I say so if config, it is my 113.11. Let me try to ping my gateway 10.10.113.1. I'm able to ping that. Let me try to ping the other test VM, that is 12. I should be able to ping because it's the same segment. It's pinging. Let me go to the other test VM. and see if I'm able to ping that. Yep. So if config, this is 12 from here. Let's say ping 10.10.113.1 is pinging, and 11 is pinging. Okay. So I'm able to ping both the test VM from each other in the same segment. Now the next step is that we will try to ping it from the router. So if I go to the here, I'm able to ping these to each other. Let's try to ping it from my physical router here under the same VRF. We should be able to ping from here to this guy. So this will take a source IP of the interface, this interface. Okay, so we can go here simply, and where is my this one here? So I'll say ping VRF red 10.10.113.1. My gateway is pinging. 11 is my test VM is pinging. 12 is pinging. So it is, if we can say what is the source it is taking, we can see that it is taking my BGP neighborship IP 12. It is the IP between my tier 0 and tier 1, and it is reaching. We can take a source IP of as I discussed that we had multiple test VRF interfaces, so which we can see that show IP VRF red loopback 60. Okay, so show run interface loopback 60 is 666 IP. Let's ping that. Ping VRF red. I'll say source ping VRF red. Sorry, red VRF. One source L60. We are able to ping using a different loopback or different network address. So from here we are able to ping. Now my next test is that let's try to ping from my laptop, because my laptop is also on the same VRF. So we should be able to ping from my laptop. Here we are. Let me ping 10.10.113.1 first. I will try to ping the gateway. I'm able to ping the gateway. The VM is pinging. 12 is pinging. Let me do a complete trace. Tracert minus D 10.10.113.12. So it is my gateway on the router. Then it is my interface between underlay and via the tier 0. This is the tier 0 and tier 1 IP address, and this is my test VM. Okay, so this is within the data center. I have another VM on the other data center. Let's try to ping if those are also pinging from these VMs to those VM. So we can simply go to my test VMs. I'm sorry, yep, this one. The IP address we have there, 10.10.13.1 is my gateway there. So we are able to ping that, the gateway, and the test VM is there, 10, it's pinging, 11 is pinging. So we are able to ping the, sorry, we try to ping from the other side also. Okay, if I go here, this is my test VM. I'll just say console. I'll show you that what is the IP this I have. Okay, this is my if config. This is 13.10, 10.10.113.11. I'm able to ping. Okay, and say 12. I'm able to ping. Okay, and we can do a trace also. Say 11. We can see that. This is the gateway. So the first hop is the gateway. So we can see here. So first hop is that this tier 1, 13.1 is here. It will come here, and then all the way this hop, all the way it will come, then all the way it will come here. So we can see at least 5-6 hops here. Yeah. Then we can see 201.1. That is 20.1 is the IP here. Then it will go 200.2. This all the way it comes here, and 200.2 this guy, and then it will have IP in between, and then to the host. Okay, this is the tier 0 tier 1 IP address, and then will be the last hop. So we can see within a data center in the same VRF we are able to ping each other. between data center under the same VRF, we are able to ping end to end, and from my test VM, which is on connected on the underlay physical environment. So my laptop is in a physical environment. From there, I'm able to ping as well. This completes my use case one. Okay, start. Now we are into the use case two. We have created another VRF, blue VRF, and we have one segment or one test VM here, and we have one test VM here. Now the test should be that we should not be able to ping from this test VM to from blue test VM to the red test VM. Also, my laptop is on red VRF. We should not be able to ping from my red VRF to this blue. From my laptop, I should be able to ping my red segment, but not the blue segment. So how we can do that? We can simply what we have done just to showcase. So the way we created the red VRF tier 0, similarly we created the blue VRF. I'll just walk through here. We had the CDC blue VRF tier 0, and it is connected to the interface. That is the interface to the underlay. This is my interface to the underlay. For the VLAN, we have this is my interface IP. So this is an IP between this guy to the underlay. So my blue tier 0 VRF is configured, and then we have created a tier 1 and connected that tier 1, blue tier 1 to the blue tier 0. Blue tier 0, this is my tier 0, and then we created a segment here for blue workload. This is my segment, CDC tier 1 blue connected to tier 1, and this is my network address 10.10.111.1. So now going back to my test VM and see if we are able to ping them. So before that, let me go to the physical router here or switch. Let's see the BGP neighborhood status for the blue VRF. Show IP BGP VPN v4 VRF blue summary. So this is my 65001. This is my BGP neighborship is up with 51.2 here, and we are receiving two routes. So we can see that what routes we are receiving. Okay, so we are receiving 1010 from 151.2. 111 is we are able to receive that. Now let's go back to my test VM and see that if it is able to ping the gateway. So this is my test VM blue VRF. Let's see the IP here. If config, we have IP 111.11. Let's try to ping the gateway 10.10.111.11. We are able to ping. Now let's check from the my router here. So see that show IP VRF blue. So we have taken a loopback 0, loopback 1, 30, VLAN 30. Let's first ping without any source IP, and we should be able to ping the workload or the test VM. Ping VRF blue 10.10.113.11. Okay, sorry, it is 111.11. It's the wrong address. It's pinging. Let's take a source as L01, loopback 1, LO1. Sorry, source. We are able to ping. Okay. So if I am here from this router, I'm able to ping this. From this router, I'm able to ping this. Okay. Now my laptop is on red VRF. Before that, let's try to ping the test VM between blue and red. Okay, so I'm on a blue VRF. Let's try to ping the red gateway first. Ping 10.10.113.1. I should not be able to ping it. It's not pinging. It's a different VRF actually. That's an isolation. It won't ping the test VM also. Okay, and we can see that where it is getting dropped. Okay, it will drop on the gateway itself because it doesn't have any route for that 113.11. Okay, And now test. Meanwhile, while we are getting the routes trace here, we can check it from my laptop. My laptop is on the red VRF. So red VRF doesn't know anything about the blue VRF. So we should not be able to ping 10.10.11.1 gateway. It won't ping because it is a different VRF, and obviously we won't be able to ping the workload also. Okay, and if we do a trace, we can see where it is getting dropped. 10.10.11.11. It will drop on the physical router itself because it doesn't know the routes. So that confirms the complete isolation between two VRF in a same data center connected on a same switch on same underlay, but it's completely isolated. That concludes my use case too.
Awesome.